Good morning, everyone. I'm Dr. Prasanti from H&S Mathematics Department, TKRAC. Today, we are going to learn about the topic regression, which is there in the second year syllabus. Now, to understand about regression, we need to know about our basic idea about correlation. Here, correlation is a statistical measure that describes the strength and direction of relationship between two variables. So it's very clear whenever we are finding a relationship between two variables means those two variables should be related to each other. So we are finding correlation between two related variables. That is called correlation. So how a particular one variable is going to change with the changes in another variable, that entire analysis is named as correlation. We have here listed out four types of correlation here. So I'll give you a brief information about this. First one, positive correlation and negative correlation. Second one, simple, multiple, and partial correlation. And the next is linear and non-linear. And last one is the no correlation. As I said earlier, the correlation, if we are finding, it should be in between the variables which are depend on each other. If we are trying to find out any relation between variables which are not at all depend on each other, that is independent variable, there we will get numerically the answer will be 0. That is called there is no correlation between the variable. That the correlation is no correlation. Now coming to this positive correlation, we can take an example here. That is a particular variable x is increasing, then the second variable y is also increasing. That is called both the variables are in the same direction. That is positive correlation. For example, as you students are attending the classes regularly, you are attending regularly to the college, then your attendance percentage is automatically will increase. So that is called positive correlation. The same like that, if you are attending college is decreased, that is you are regular to the college, very irregular, then your attendance percentage is automatically decreased. That is also called positive correlations. You should have a clarity here. That is, both the variable are in the same direction, either increase or decrease. So if both variables are increasing together in the same increasing together, that is called positive correlation. Or both the variables are decreasing together is also called positive correlation. Then what about negative correlation? So it's very clear here. Negative correlation means one variable is increasing and another variable is decreasing, or else one variable decreasing, the second variable is increasing. So the change in one variable reflects opposite change in another variable, then both are in the negative direction, opposite direction. That correlation is called negative correlation. For example, we all know that is if price increased, automatically sale will become decrease. That is called negative correlation. And otherwise, if the offers are more, that is price decreased, 1 plus 1 offer, 2 plus 1 offer, like that. If price decreased, automatically sales are going to increase. That is called a negative correlation. So you should have a clarity here to understand the positive correlation. That is, both the variables are moving in the same direction, either increasing or decreasing. It is called a positive correlation. Or one variable increasing, another is decreasing. So both the variables are in opposite direction. That is called negative correlation. Coming to the next one, simple, multiple, partial correlation here, and we can include total also. So simple correlation means to analyze or to understand about correlation, sure, we need to know about two variables. So that is, we need two variables to analyze correlation. That's called simple correlation. And then more than two variables, if you are using to analyze or to understand the relation between the variables, more than two variables if you are using, that is called multiple correlation. Even though we have more than two variables, but at a time, we are considering two variables for our analysis, all others are partially constant. That is called partial correlation. So we will come here, we will take an example here, that is, so for example, price of a commodity decreased, like offers, what we discussed now. So automatically sales are going to increase. If sales are increased, company need to increase their products, that is manufacturing should be speed up so that they have to give more quantity of products to the market because their sales increased. So to improve their, to increase their productivity, what they have to do, they should increase their manpower or else machine power or else material or else they need more money or else they need more time. So it is a chain basis. You can understand more variables can be included here. It is a multiple correlation. But even though we have more number of variables for analyzing this example, we can take at a time only two variables. For example, manpower and machinery. So how many manpower are there? How much manpower is available for the company and how many machines are available at that time? So like that, two variables we can take at a time to calculate the relationship, that is called partial correlation. Now coming to the third one, linear correlation and non-linear correlation. When we are going to find out this correlation, if you are able to observe a steady rate in the graph, or else if you are plotting a graph between x and y, you are able to see that line is a straight line. So linear, that correlation is called linear correlation. Non-linear correlation means, like best example, gold rates. There is no particular constant rate we can understand. It's always fluctuating like our heartbeat. So non-linear correlation, that is we can see more up and downs in the data, that is curve linear. The another name for non-linear is curve linear. As we discussed, no correlation is nothing but when we are able to, we are unable to finalize the correlation between variables because those are independent to each other. Now, mathematically, if we will solve this positive correlation, negative correlation, and no correlation, three values we will get mathematically. Karl Pearson correlation coefficient. So positive correlation will give you the value in positive terms, and negative correlation value will give you in negative terms, and no correlation is 0. But positive terms, negative term is you won't get the value more than 1. So correlation numerically lies between -1 to +1. That is the boundary for correlation. Moving forward, this is a graphical representation of correlation, that is the scatter diagram. I gave here three types of diagrams for quick understanding: positive correlation, negative correlation, and no correlation. We can tell about more in depth about this. This is perfect to positive, high degree of positive, like that we can discuss, because you can see the scatter diagram means points on x and y plane or axis. You are plotting all the points on the xy plane. Okay, so the scatter, how the points are together, how much degree of relation is there in between the points, you can understand. You can see the no correlation graph. We can't identify like all the points are like stars in the sky. So there is no a particular shape for that. But when you are seeing a positive correlation, it is a constant steady line going on upward direction. This is called linear sometimes. Okay. Now a negative correlation, if you see the line coming downwards. So more clearly, positive and linear, negative and linear, and see the diagram C, that is curve. It is non-linear. It's like a shape of curve linear. And the fourth one is, as we discussed, that is no correlation. So these are the simple thing to understand about correlation. Now, our topic is regression. That is, after identifying the correlation which is positive or is negative, and that too it is a perfect positive or perfect negative, we can able to continue the correlation as a straight line going on upward direction or downward direction. Then we can convert that points which are correlated. Those points can be converted into a line. Y is equal to mx plus c. You all know as a mathematically a straight line equation. So in that way, if you are converting correlated data into straight line form, that gives you regression. So see here, what is the meaning of regression? Regression analysis is a statistical method used to examine the relationship between one dependent variable and one or more independent variable. Now you should understand here the difference between correlation and regression. For example, correlation, while we are discussing, both the variables or all the variables should be related to each other. That is called correlation. Okay, and all are depend on each other. Now coming to regression, All the variables are related to each other, but in that few are dependent, few are independent. So see here, I just listed out here simple linear regression. For example, y is equal to a plus bx if you wrote. So same line, the regression line, y is equal to mx plus c. In that way, if you are writing y is equal to a plus bx, so we are finding the value of y with the help of value x. So you can understand clearly y is a dependent variable on x. So this is called regression line of y on x. Okay. So that is regression aims to understand how the dependent variable changes at independent variable varies. So how you are going to change x variable? If you are taking example, y is equal to 2 plus 3x. A simple example you can roughly imagine. Y is equal to 2 plus 3x. X value you are going to change. X is equal to 0. You will get y equal to 2. If you are writing x is equal to 1, y equal to 5. So that is the way x value you have you have a freedom to change x value because x is an independent variable. But according to changed value of x, you are getting y value because y is dependent on x. So that is called regression line of y on x. As usually, you know, a is from your straight line, y is equal to mx plus c, m is the slope of line. Like the same thing here, a is a constant value, or else you can also say intercept point on y-axis. Moving forward, x is equal to a plus by. If I am writing here also, how we understand y on x, x is equal to a plus by is nothing but a regression line of x on y. Here x is dependent and y is independent. So depending on the situation, if we considered x is equal to price, y is equal to sales. So at any time, if you are changing price, what will be the sales? You can analyze. Or else at any time, if the change of sales are there, what will be the price? You can estimate. That is the logic of regression. Now, I'll take a few example problem to explain you how we can calculate this straight line. So I'm considering here y is equal to a plus bx, one regression line. So writing this normal equation, that is NA plus B summation x is equal to summation y. And the second equation, A summation x plus B summation x square is equal to summation xy. These two are called normal equations. We are going to get these two equations with the help of least squares principle. It is very easy to understand least squares principle. For example, if you are taking y is equal to a plus bx is your base equation, starting equation, regression line of y on x. Okay, so simply apply summation on all the sides, means left side and right side. You will get the first value, summation y is equal to NA plus B summation x. To get the second normal equation, just multiply with the independent variable. So you are multiplying with the independent variable, you will get the main equation as xy is equal to ax plus bx square. Now again apply your summation symbol so that you will get second normal equation. By solving these two normal equations, you are able to get the values of A and B. Substitute the values of A and B to get required regression line of y on x. Here, considering a small example, directly I just wrote it here the values without giving list of values of table. So n is equal to 7. 7 values are there in x series and also 7 values are there in y series. And summation x is 113. Summation x square is 1983. Summation y is 182. And summation xy is 3186. Okay, because depending on that one, you can see my cursor point. Depending on that, we need only summation x value, summation y value, summation x square value, summation xy value. So required values we consider. Moving forward here for the solution. So considered y on x as y is equal to a plus bx is the equation 1. And these two equations considered, normal equations are 2 and 3. Substituted those values in equation 2 and 3. I got equation 4 and 5. Simplifying equation 4 and 5 in a mathematical way, you know, here 113b value is there and 113a value and 7a is there. To equate a or as to cancel the a value, I am just multiplying equation 4 with the 113 and multiplying equation 5 with the 7. With that, this is the result. You got the value. B is equal to 1.56. Students, please cross check either you got the same answer or not. Substitute the value which we got with the solution B value in equation 4, you'll get the A value 0.82. So substitute here A and B in equation 1, y is equal to A plus Bx. This is your required line for regression line of y on x. Now, here you can substitute any x value to get any y value. That is a particular company, 2020, what is the profit? X value is 2020. Now 2021, 22, 23. You can change the X value so that you can get the Y value. So I think you understood the logic here.